Hi friends, welcome to LTechpedia. Now we will discuss about GATE question paper 2016 for the concept of control system. So we will go for the concept. The first problem, the phase crossover frequency of the control system transfer function of 100 divided by s plus 1 whole power cube in the radian per second. So they were required the phase crossover frequency, so that is in radian per second. So in this they were provide the transfer function like a 100 divided by s plus 1 by 3 whole cube. Then we want the function of angle. Phase means angle, phase crossover frequency, so omega pc they were required. So phase crossover frequency for the given transfer function is, this is 1 s plus 1 divided by s plus 1 power 3, that is in denominator. So the whole term is converted as 3 times, so minus 3 tan inverse of s plus 1 is written as tan inverse of omega. In general, we want the phase crossover frequency. We know about the formula. Angle of g j omega at the omega is equal to omega pc is equal to minus 180 degree for this case. So equating the both the section, so both the section means equation this one and second equation this. So equating means minus 3 tan inverse of omega pc equal to minus 180 degree. From this minus minus will be cancelled, then 3 cancellized into 60. So we want to omega value, so tan inverse will be come inside. So omega pc is equal to tan of 60 value, so that is equal to root 3. So final answer omega pc is equal to root 3. This is final. This is the final answer. Next, move to the second problem. So in this problem they were provide transfer function of system is y of s divided by r of s, that is equal to s divided by s plus 2. The steady state output y of t is a cos 2t. So they were provide y of t, that is output function a cos 2t plus 5, for the input r of t value cos 2t. The value of a and phi respectively. They were want a magnitude, amplitude value of a and phase angle value phi. Then we write the function. Given function is y of s divided by r of s, that is equal to s divided by s plus 2. Then input is r of t is equal to cos 2t. Then we substitute the value of omega. So comparing this one cos 2t, so in this function omega is equal to 2, so replaced in this value in r y of s value. Then substitute the function s is equal to j omega, omega is equal to 2. Then substitute in this function y of s at the function of s is equal to j2. Then substitute in the above transfer function. So here substitution means 2j divided by 2 plus 2j into r of s. We know the value of r of t, so cos 2t value substitute here. Same function will be rewritten in the time function. So 2j plus 2j, 2 plus 2j cos 2t. So this is rewritten as y of t is equal to 1 by root 2. So we will consider the whole function will be rewritten as 1 by root 2 cos 2 phi 45 degree. This is considered as equation 1. They were provided already output equation here. So y of t is equal to a cos 2t plus 5. Then comparing both the equation, we get the function a is equal to 1 by root 2 and phi is equal to 45 degree from the equation 1 and 2. So this is final answer. Then move to next problem. Consider the following asymptotic Bode magnitude plot, omega in radian per second. Which one of the transfer function is suitable for the above Bode plot? They were provide one Bode plot. For this Bode plot, which transfer function is suitable? So we know about the transfer function, how to derive from the Bode plot. So we will see in one by one. First we calculate k for this given problem. So they were provided totally 3 slopes. So first slope is upward plus 20 dB, that is one upward means numerator. So the Bode plot k map will be drawn by upward. So first upward it is in joined from the origin. So k into s divide by the 20 will be equalized, means minus 20 is here present. So here one value of s is presented, s plus a, then here minus 40, this is minus 20, that's why here rewrite as s plus a, denominator of s plus a minus 40, so s plus b the whole square. So this is the whole square, means 40 degree. So plus 20 means into s, minus 20 means divide by s plus a function. So this is the overall transfer function of given problem. So in this problem we want to find k value, a, b, corner frequency values. So we will calculate one by one. So first one, to find the k value, so k value means it will be equalized to log 20 log is equal to 20 log of 0.5. so that is the 0.5 will be taken from this origin value 0.5 where it is merged. So 0.5 k is equal to, here only the 20 dB will be indicate, so 20 log of 0.5. so here consider 20 log, that is k is equal to value of 2. So where the function 2s is presented, then we go to the corner frequency omega 1 and omega 2. These twos are not a corner frequency, 0.5 and 0.5 and 8 are not a corner frequency. We want to find out the corner frequency omega 1, omega 2 here. So we want to both omega 1 and omega 2 value. So we calculated omega and omega 2 with respect to, for omega 1 20, so the dB is considered as 20 log, so 20 dB, so this is 20 dB is equal to 12, so 0.5 integration, so here 12 minus 0 divided by log omega 1 minus log 0.5. so in between the value, so it will be considered here, so 0.5 minus with the log of omega 1. so we want to omega 1 value, so the omega 1 will be calculated as log omega 1 minus log 0.5. from this equation we calculated omega 1 is equal to 2. Similarly omega 2, so here consider second slope is 40 degree, so second slope 40 degree, it will be taken as this one. So from this 40 degree 12 minus 0, it will be replaced as here 8 log 8 minus omega 2. This consideration here it will be taken as from this, so here log 8 will be taken. So at finally we want to take the value of omega 2 value, so log 8 minus omega 2, it will be simplified as we calculate omega 2 is equal to 4. Then substitute the function, already I told, for given transfer function ks divided by s plus 1 term, then s plus second b the whole square. So from this equation 1 plus s divided by t1 is replaced as omega 1, t2 is replaced by omega 2. so it will be written as 1 divided by 2s plus 1 divided by 4s square, so 0.5 s then 0.25 s square. This is the final answer for given problem. Next, move to next problem. Consider the following state space representation of linear time invariant system. So they were provided one LTI system. For this system they were want output function at the time of t is equal to log e2. So x dot is equal to, in a state space representation, x dot is equal to x a plus bc, like that it will be created. So x dot will be written as x dot is equal to x into a plus b into u. So similarly y is equal to c into x plus d into u. U is the input vector. So here they will provide the x dot is 2 cross 2 matrix of xt. So a matrix is 2 cross 2 1 0 0 2. Then find the value of EA of t. E phi of t we want to find. So EA of t is equal to Laplace inverse of Si minus A the whole inverse. So Si minus A, we have the function A is equal to 2 cross 2 matrix 1 0 0 1. So substitute in this function Si minus a, so si minus a, that is equal to s minus 1 0 0 s minus 1, take the inverse, so it will be inverse, consider as 1 divided by s minus 1 0 0 1 divided by s minus 2, then take the Laplace inverse. So Laplace inverse for EAFT. So EAFT is equal to inverse Laplace of SI minus A inverse. So that is equal to 1 divided by S minus A. So S minus A will be considered as e power plus. In case S plus A means e power minus. So it will be 1 divided by S minus A replaced as e power t. Similarly, S minus 2 replaced as e power 2t. This is the value of e of t, but we want y of t at the time function of log e2. So y of t, they were provide function c transpose x of t. So we find the function of x of t, then move to the x of t is equal to e of t into c. So here the consider e of t into, this is the value, so the x naught value will, they were provided, e naught we want a function x of t, so e of t into x of t value, x of t they were provided, x naught is equal to 1 1, substitute here x naught, so e t 0 0 e power 2t 1 1, take a matrix multiplication, e of t into 1 e of t 0 into 0 0, so then e of t into 1, then 0 into e of 2. So finally we got e of t e power 2t. Then we want a function y of t. Y of t is equal to c transpose x of t. C transpose means the column matrix will be replaced as row matrix. We know the x of t, now only we calculate et 2 power t. So substitute here 1 1 e power t e power 2t, then it will be calculated in a matrix form. So 1 into e power t plus 1 into e power 2t. So this is the final for y of t, but they were required for the function t is equal to log et. So substitute t is equal to log e power 2. So substitute here, so base of e at the time of log I have 2, so substitute e power log e2 plus e power 2e log 2. E power of log will be replaced in the term of e term, only coefficient consider. So 2 and 4 will be taken as the countable. So 2 plus 4, the final answer is 6. So this is the final answer for given problem. Next problem. Loop transfer function of a feedback system is g of s h of s is equal to s plus 3 divided by s square into s minus 3. Take the Nyquist contour in the clockwise direction. The Nyquist plot of g of s h of s encircles minus 1 plus j. So given problem, they were provided one transfer function s plus 3 divided by s square into s minus 3. So from this function, they were want to how many times clockwise direction contour is counted. So we calculate from this given function s plus 3 s square plus into s minus 3. From this characteristic equation, 1 plus g of s into h of s. So add the 1 plus, take the cross LCM, multiplication and cross LCM. So 1 plus into s plus 3, so s square into s minus 3 multiplied. So we get s square into s minus 3 plus s plus 3 equal to 0. Then it will be multiplied inside. So here s square, so square will be multiplied as s cube minus 3s square plus s plus 3 equal to 0. Then go to the Nyquist contour calculation. For this consideration, we move to the Routh-Hurwitz criterion. For Routh-Hurwitz criterion taken as higher value of coefficient in the given polynomial. So s cube is the maximum. So order of 3, take 3. So 3 is the odd number. So we write the first one s3, then s2, s1, s0 like that. So first s3 means first row taken as coefficient of s3 and s1. That is power of odd numbers. Those who are coefficient will be rewrite as. In case s power 1 is not available means it is written as 0. So consider as here s power 3 coefficient is 1 and s coefficient is 1, rewrite, and s square coefficient is minus 3, s of 0 coefficient is 0. Then taken as s power 1, we want to value of s power 1, so we take the multiplication minus 3 into 1 and 1 into 3, so total value is minus 6 divided by this value at the corner, so minus 3, so we get a final answer plus 2. Similarly we calculate this one. So from this equation, normally we clearly know about the function of Router's criterion. It shows actually once the sign changes is occurs means the system is said to be unstable system. So it crossed the poles are lies on the right half of the S plane. So here 1 minus the first column shows 1 minus plus 2, that is plus 2 minus, from the sign change occurs plus then minus then plus, here two sign changes are occurs, plus 2 minus minus 2 plus, so totally two poles are lies on the right half of the S plane. So those who are right on the S plane, those are considered as zeros, left half of the S plane considered as poles here for the n circles. So how many sign changes occurs? 2, that is equal to 2, then number of poles is 1, so totally 3, s power 3 having the 3 poles, so that is considered as s power z2 p equal to 1. We want number of circles in the contour, so n formula for this one, n is equal to p minus z, p is equal to 1, z is equal to 2, the final answer is minus 1. The minus 1 indicate, 1 is indicate number of circles, that is countable number, so number of circles 1, minus is indicate clockwise direction, that's all. So here only one cycle is occur, so how many changes means number of changes created unstable system, then it will be counted means n is equal to p minus z. So here n is equal to p minus z, that is equal to 1 minus 2, it indicate minus 1, so total function the system encircled with only once. This is the final answer for given problem. So next problem, s cube plus 5.5 s square plus 8.5 s plus 3 is equal to 0. So from this polynomial, the number of roots of polynomial which have real parts strictly less than the minus 1. So this polynomial have some roots, that is this is s power 3, so anyway it has totally 3 roots. In this 3 roots, how many roots are the value contained as the minus less than the minus 1 value? So we calculate first the roots value, so s square plus 5.5 s square s cube plus 5.5 s square plus 8.5 s plus 3 is equal to 0. Then in this function we want to consider, for our clarification we will rewrite as s cube plus 5.5 s square will be rewrite as 3 square plus 2.5. Similarly 8.5 s will be rewrite as 7.5 plus 5. So then it will be once again rewrite as, we take the function of s square itself, this is multiplication, so we take the function of s square, so s square means s square into s plus 3. Similarly here 2.s5, so this function we take 2.5s, so s plus 7.5 is multiplied of 3, so s plus 3, finally s plus 3. The overall function considered as s plus 3, s plus 3, s plus 3, taken out as s plus 3, then at final we got s square 2.s plus 1, so it will be rewrite as s square plus 2.5s plus 1 is equal to 0. Then from this equation we will easily get roots of the characteristics. So s plus 3 is equal to 0 means s is equal to minus 3. Then s square plus 2.5s plus 1 is equal to 0. It will be calculated as minus b plus or minus square root of b square minus 4ac divided by 2a. From that equation we calculated as the two roots, so it will be simplified as minus 2 comma minus 1.2 value, so it will be having the value. From this equation they were want to how many poles are having the less than the minus 1 value. Here 1 by 2 is considered as minus 0.5, so it is greater than the minus 0.5 is greater than the 1 value, minus 1 value. So minus 2 and minus 3 are less than the minus 1 value, so total number of poles are minus 2. So this is the final value. So here countable as two poles are having the value less than the -1. That's all. So these are the problems asked in a GATE question paper 2016. Consider a control system concept. If you like this, you will like and share to your friends. Subscribe my channel. Thank you.